Hello, thank you for staying tuned. Today we are going to look at geometric series, and under geometric series we are going to look at the sum of terms in a geometric sequence or a geometric progression. So presented with a geometric sequence whereby between two consecutive terms there is a common ratio or a common constant multiplying value. How do we find the sum of terms in that geometric sequence? Now, looking at the sum of terms in a GP. Now, when given a geometric sequence whereby the first term is A and the common multiplying value or the common ratio is 4, and then the number of terms in that sequence is n. Then for us to find the sum of terms, then the sum of n terms of the GP is given by sum of n terms equals to a into brackets r raised to n minus 1 close the bracket over r minus 1. Now this formula is applicable when the value of r, that is the common ratio, is greater than 1. When the value of r is greater than 1. Going ahead, we also have a situation whereby the value of r can be less than 1. So when the value of r is less than 1, how does the formula go? Now, alternatively, the sum of n terms equals to a into brackets 1 minus r raised to n over 1 minus r. And this second formula is applicable when the value of r is less than 1. The value of r is less than 1. When the value of r is more than 1, we use the first formula. When the value of r is less than 1, we use the second formula. So we are going to clear everything and preserve our two formulas to be used in tackling questions on a geometric progression. Now, we have a question, but you have been given a geometric sequence of 8, 24, 72. So find the sum of the first 6 terms. Now, looking at this sequence, we can actually deduce that from this sequence, the first value is 8. The number of terms, we have been told to find the sum of the first 6 terms, so n is 6 and the ratio is 3. Because from 8 to 24, they have multiplied by 3. From 24 to 72, they have also multiplied by 3. So the value of r is 3. Now, in this case, the value of r is more than 1. Given that the value of r is more than 1, we are going to use the first formula. We choose the first formula. Now, equating the values of this one, we're going to end up with 8 into brackets 3 raised to 6, because the value of n is 6 minus 1 over 3 minus 1, which simplifies down to 8 into bracket 729, because 3 raised to 6 is 729 minus 1 over 3 minus 1, and this one boils down to s of 6 equals to 8 into bracket 728 over 2, and this one gives us 2912. So the sum of the first 6 terms of this geometric sequence is 2912. We'll clear out this one and look at next question. Now, looking at the next question, it says that the sum of the first 3 terms of a GP is 31 if its common ratio is a fifth, that is 1 over 5. Calculate the sum of the first 8 terms of the series. Now, we know very well that the value of n here is 3, because they've said the sum of the first 3 terms. So n is 3, r is 1 over 5, s, that is the first 3 terms, so s3 equals to 31. The sum of the first 3 terms is 31. So what we don't have is a. They want us to calculate a first. Then from calculating a, we can find the sum of the first 8 terms of the series. Now, you can see that the value of r is a fifth, which is less than 1. Given that the value of r is less than 1, we use the second formula. So in the second formula, we'll quote all the values above here, and you end up with this one, which now simplifies down to the value of a equals to 25. So the value of a is 25. So they want us to find the sum of the first 8 terms. Now, we have established that we are going to use the second formula because the value of r is less than 1. So equating the value of n as 8, the value of r as 1 over 5, the value of a as 25, we'll have s of 8, or the sum of the first 8 terms equals 25 into brackets 1 minus a fifth raised to 8 over 1 minus a fifth. So the sum of the first 8 terms of the series is going to be 31.24992 or 31.25. That is, you round off into 4 significant figures. Also clear this one and look at another question also. Now, the question says, the fourth term of a geometric sequence is 192. If the first term of the sequence is 3, find the common ratio, then find the number of terms that will give a sum of 255. Now, for a geometric sequence, how do you find the nth term? The nth term of a geometric sequence is found by ar raised to n minus 1. A is the first term, r is the common ratio, n is the number of the nth term minus 1. So we've been told the fourth term is 192. So it means that the fourth term, that is ar cubed, should give us 192. You've been told that the first term of the sequence is 3. So the value of a is 3. So it means that 3r cubed is equals to 192. Divide both sides by 3. So r cubed equals to 64. Find the cube root on both sides, or you multiply both sides by 1 over 3. Multiply both sides by a third, and you end up with r equals to 4. So it means that the common ratio of this sequence is 4. Now, since we found that the common ratio r is 4, it means that the value of r is greater than 1. Given that the value of r is greater than 1, we are going to use the first formula. So equating the value of a as 3, equating the value of r as 4, we end up with 255, because they have said the sum, find the number of terms that will give a sum of 255. So 255, which is the sum, equals to 3 into brackets 4 raised to n minus 1, close bracket, over 4 minus 1. This one translates to 255 equals to 3 into brackets 4 raised to n minus 1 over 3. And this one boils down to 3 cancelling 3. So you end up with 255 equals to 4 raised to n minus 1. Add 1 on both sides, so it means that 256 equals to 4n. Now we can use logarithm to solve this and find the value of n, or you can express 256 to the base of 4. Now 256 to the base of 4 is basically 4 raised to 4. So 4 raised to 4 equals to 4n. Now when the bases are the same, according to the laws of indices, when the bases are the same, according to the laws of indices, then the value of n is going to be 4. The value of n being 4, then it means that the number of terms that will give a sum of 255 are 4 terms. 4 terms. So thank you for watching and learning. You can like and subscribe to my social media handles. That is on YouTube and Facebook. Thank you.